Hey everybody, this is Larry. This is day 21 of the Leetcode May Daily Challenge. Hit the like button, subscribe button, join me in Discord. Let me know what you think about today's problem, today's contest, everything in between. What did I do? I just kind of did some strength training today, just some squats, very light squats at like, I don't know, 180 pounds or something. And I went to the Yankee games. The Yankees won, so that was exciting. Next game is tomorrow, so very excited. Let me know if you're following the NBA and who you're supporting. Anyway, let's take a look at today's problem. We have 73 set matrix zeros. Given it a matrix with element zeros has entire row and columns of zeros. You must do it in place. Okay. Basically, okay. I mean, I think this is pretty straightforward, right? Is it not? A straightforward. Yeah, I wasn't going to use that much extra space. We're supposed to use it in place, right? So of course we want to do it in. Okay, symbol improvement. I guess that's the one where you just keep track of the rows and columns. Can I do it in constant space? Yeah, I mean, I feel like there is definitely like I don't know, like you could do it in 2 passes for sure, right? Which I don't know how I feel about that, to be frank. Yeah. The 2-pass solution, because I don't know, I don't know if this is one of those problems, but there are some problems where the trick is that you just use an extra bit. Kind of like, I guess this is actually the entire float of int, so it's actually kind of hard to do that. But, yeah, I don't know, it's tough to say. Uh, Let me think about this real quick. I mean, yeah, just to be clear, like of course we can do this algorithm, and we can do it. This one, that's just make a boolean list of the rows and the columns, and that's very trivial. Can I devise a constant space solution? That's what I'm trying to work on, and an in-place solution. And yeah, and yeah, maybe we could use like, you know, I wouldn't say that if you make a bucket of like 200 elements, that doesn't count for me. But yeah, how would I do it? I wonder if you could do something with, I don't know. Honestly, these kind of problems always I'm a little bit weaker at, because they're not very practical. It's just often just like something with one trick. But this one, I don't know that I know this one. I think the idea may be I think, okay, so you can definitely reduce it to the smaller one, right? Just by doing one as you get it, and then doing the other, like if you do rows and then you do the other do columns as you get it. But that's still not constant extra space, right? So how is there a way that I can kind of do a scan? Yeah. Hmm. Because I'm going to pretend that, for example, that we cannot use like convert it to a long. If you convert it to a long, that kind of kills the point of this problem. So I think that's like not in the spirit of this problem. But I am, honestly, I'm not going to lie, I am struggling with this problem. I'm not like, I don't know. How do you do it with both things, right? Can I do it in like a weird diagonal way? That's the way that I'm trying to kind of figure out how to visualize, but maybe I'm not able to visualize it without drawing it out, right? But my thing is that, okay, if you have, maybe I'll draw it out, but I'll draw it out on the screen. I don't know why my computer's spotlight is like having issues. I have to like search for apps and stuff. Maybe I need to reboot my computer. It's probably time. I don't reboot my computer often enough. But okay, so, and I hope that this isn't some like weird hacky tricky thing. But okay, so let's say we have a matrix, right? You know, drawing it terribly, right? So first we process, without loss of generality, right? We can process the first row, right? So what happens? So there are only two cases, which is that if it doesn't have 0, then that's fine, right? But if it does have a 0, let's say we have a 0 here, right? What does that mean? Well, yeah, I mean, because then now there are two things you can do, right? You could process, you know that there's a 0 or maybe even multiple zeros, but for now we'll just say 1. We can process the rows or the columns, right? And I don't know that there's a way to do that such that you mark it as done and then come back, right? And the thing is that like you can't just remove these rows either, right? Like, because for example, if you try to remove, say, I mean, the row, I guess you can do it in this way. But let's say there's another 0 here. That also means that, you know, you want to factor in. So you can't just be like crossing out the cell and not process it. But, and I'm trying to think whether there's like a DPE solution, right? And what I mean by that is just that, okay, let's say we want to process the row. Okay, we know that this row is good, right? But can I do it backwards? Like, and I don't know that that's true, but for example, if we can maybe just cross out this 0 when we get to here, we get to this cell, we say, okay, well, there's a 0 on top, so we can just convert this to a 0 without worrying about the rest, right? Can I do that? But the thing is that if you cross these out, then like these are not real zeros, or like the zeros that we have to care about. So okay. I think I have an idea. And based off, so we do it one row at a time just because without loss of generality, right? But then now, so let's say we want to only, yeah, okay, right? So then now here we first, so for each 0 we want that we see on this row, right? Actually, is that true? Maybe that's not true. I wanted to say something, but I don't think that's right. Because I want to say that like maybe I could just like drop down, right? But then if you have 0, then how do you tell that this 0 is different from all these other zeros, right? I don't know that I know how to do this one. But I'd figure out how something like this. Like I feel like there's an ordering in which maybe it gives us some information, but okay. So maybe what if we do some kind of weird diagonal thing? And honestly, I don't know how if this is right. It's just that I'm throwing out random ideas because I don't have any idea at this point. I mean, this is the user's problem, but that's besides the point. So let's say we have here, right? What does that mean? Hmm. I don't know. I think what I'm trying to figure out now is just some properties that we can take advantage of. It is such an ad hoc problem that I don't know that I know how to do it. Um, okay, let's say we take this out. Let's say we have. Wait, what does that mean? Can we store it somewhere? Can we just? Like here, so that we later pass on. I see. Okay, maybe that would work. So basically now we're just using the first row and the first column as the thing. In that case, okay, like so then what I'm doing now is that I'm ignoring the first row and the first column, right? And then as a result, then we just need one more variable, right? Is that right? So basically we're saying, okay, sorry, I know I'm not explaining it that well yet because I'm trying to convince myself that this works first. But basically, we're using. Yeah, we're using the first row and the first column as a representative of the entire matrix, right? So instead of so in theory, you could think of it as this, right? You could think of it as okay. I know that I'm not explaining it well because I'm not understanding it well, or I'm not. Yeah. So basically, we're okay. I see. I think I see it. It's just that then now we need two more variables and we should be good. Okay. So basically, what we're doing for this problem then is just that we're using the first row and the first column as the Boolean value. The way that you can think about it is that maybe you can convert the first row and the first column into a Boolean thing just for the first row, right? Whether the first row is true, we'll just skip columns for now because it's a little bit so that I don't keep on have to say rows and columns. But let's just say focus on the first row for now, right? Then now what we want to do is convert the first row into, let's just say we have circles in these places. Then now we just convert the first row, right? And then the question is, then now this thing, this row, allow us to later, which we will take care of, mark downwards or these other things, right? In two layers. And the reason why the two-layer part is important because we're going to do the rows. But then as a result of this, the only thing that we don't know is whether there's a real zero in the first row, right? And that we handle by one more variable, by having just by checking it whether the first row has a zero or not, and we just track it separately. And if it does, then we also, by the way, that means that we want to throw out the first row later. That's all. Otherwise, we still keep track of all the zeros in the first row, right? And then we do the same thing for columns, right? We do the same thing for columns. I'll change the color for columns, right? So I guess for here we were doing, right? And maybe there's no real ones in the first one, but then now, and then on the second pass, we'll fill out the rows, right? Using the ones on the first column. And then to know whether we fill out the first column, well, we just have one more variable of whether there was one to begin with. And I think that should be it, right? Is that right? I think that's reasonable, right? And the reason why I say that I have a dynamic programming idea from this is that you almost like this row, or sorry, this cell is based off like an AND statement. Like you think of it as Boolean, as an AND statement of all these other cells, including itself, right? So then now, this first cell is an OR statement. Did I say AND? I meant OR statements of any of these zeros. And then so each cell in the first row would have that. But because of that, you lose information to know whether there is a first, because you're using that storage, but then you can compress that storage on the first row, whether that has a Boolean. Okay, I think that sounds right. I don't know that I'm describing it right, so maybe hopefully in code it'll be a little bit better, right? So let's try it. I guess in the past I must have done it. I mean, of course, clearly, but obviously I don't remember this at all. And it's been 16 minutes, actually not so bad, but yeah. Right, so okay, so then we have first row contains 0, right? Yeah, row 0, first row 0 is equal to false, first column 0 is equal to false. I don't know why I wrote it, right? Okay, if we just do it first, right? So yeah, if matrix I of 0 is equal to 0, then first column 0 is equal to true. And then for j in range of C, if matrix of 0j is equal to 0, first row 0 is equal to true, right? And then now we'll fill out the rest in that for I in range of R, for j in range of C, if matrix ij is equal to 0, then matrix of I0 is equal to matrix of 0j as equal to 0, right? Okay. And then now that we have, basically now we're having two Boolean arrays, right? That we wanted to, but we compressed that into the first row and the first column, right? So in theory, I guess another way to think about it is that instead of writing, say, maybe another way you could have written it is like, you know, row is equal to false times n or something, or C, and then column is equal to false times R, right? So that means that for each column, no, the other way around. Maybe I was trying to be too cute. For each row, we're just saying that whether, yeah. For each row is saying that whether there's a 0 in that row, but then now instead of that, I just directly converted it to the first. For the row one will be this one. No, this one. Sorry. For the row one, it'll be this one. So we just directly converted to 0. So we basically, you can think of, and I kind of, okay, let me just write them out. So like this, you can think of this as row sub I is equal to true or something like that, right? I mean, I'm gonna remove this code because we don't use it, but right. So that's basically the idea. And then column j is equal to true, and then now we go for I in range of R, for j in range of C. Oh, actually, I messed up. This should skip the first item, right? The first row, because we have these in two things. But then here now we go, and also we skip the first thing, I suppose. Maybe a little bit off, but I think the idea is right. But then now if matrix sub I of 0 is equal to true, or equal to 0, I guess in this case, then matrix of ij is equal to 0. If matrix of 0j is equal to 0, then matrix of ij is equal to 0. And you can think of this as just saying like if row sub I is true, then we just set the rest of the cells. And then of course the notable thing is that we do skip the first row and the first column, but that's what we have this for, right? So if first column is 0, then we just convert all to 0, because now that we used these if statements as the placeholders, then now we'll get rid of them. And then now for j, is it j? So the first column, I forget which one's which, but yeah, if this is right. So the first, so the first column contains a 0, then we just want to set the first column to 0, right? That's what we're doing. So if the first column is 0, that means that we vary the row, right? Okay. 0, and then if first row 0 for j in range of c, and that should be good. Hopefully I didn't miss a corner or something weird. But let's go quick submit. Okay, good. Yeah. How did I do it last time? Did I do it for, I feel like I would remember this, but maybe not. Oh, I did not. Well, I mean, clearly yeah, I just did this in the I didn't do it with the constant space solution, obviously. I did this one, so that was kind of not helpful. But this one, I mean, but yeah, I do also want to point it out, like this comparison, right? It's very similar. It's just that instead of instead of having rows and columns doing this way, we incorporate it into the first row and the first column. But as a result, we lose the information from the first row and column, and that's why we have this thing. But yeah, this is going to be linear time, I guess, all of one extra space. The only extra space we have these two things. But honestly, I think this problem is useless, and maybe that's why I didn't solve it last time. It's kind of just like, I don't know, it just doesn't come up that much these days because memory is cheap. Maybe like 20 years ago, it could be an interesting interview problem, but I don't know. I don't find it interesting, and for competitive, I can't assume it comes up that often. So yeah. Anyway, that is all I have for this one. Let me know what you think. Thanks for watching, and yeah, stay good, stay healthy, it's a good mental health. Go next. I'll see y'all later and take care. Bye bye.